The Sun is 93 million miles away from where you're standing, and we just sent a spacecraft to within 3.8 million miles of it. To put that in perspective, if the distance between the Earth and Sun were down to just 1 meter, Parker Solar Probe flew to within just 4 centimeters of the Sun at 430,000 miles per hour, fast enough to travel from Los Angeles to New York in about 20 seconds. No human-made object has ever been this close to a star, ever, in all of human history. And what it found when it got there, scientists are still trying to process it. Before we talk about the spacecraft, we need to talk about the man it's named after. In 1958, a 30-year-old physicist at the University of Chicago submitted a paper proposing something radical: that the Sun doesn't just sit there radiating light, it's constantly exhaling, breathing out a supersonic stream of charged particles in all directions, filling the entire solar system. He called it the solar wind. Two of the most respected reviewers in astrophysics rejected it. Physically impossible, they said. But the journal's editor, a future Nobel Prize winner named Subramanian Chandrasekhar, found no errors in the mathematics, overruled them both, and published it. 4 years later, NASA's Mariner 2 confirmed every single prediction. The ridiculous idea was right. Parker went on to become the father of heliophysics, the entire field of solar science. In 2017, NASA did something it had never done before. It named a major mission after a living person. Eugene Parker was 91 when he watched the rocket carrying his name launch into space in 2018. He passed away in March 2022 at 94, just as his probe was beginning its deepest dives into the Sun. He never got to see the full results, but the discoveries, they're his legacy. Now let's talk about the machine itself, because building it was almost as audacious as the theory it was built to prove. The Sun is not just hot, it's violently, incomprehensibly hot. The surface, called the photosphere, sits at around 5,500 degrees Celsius. That alone would vaporize most materials we know of. But the corona, the Sun's outer atmosphere that Parker flies through, it reaches over 1 million degrees Celsius. 1 million. Getting a spacecraft to survive that isn't a question of heat shields alone. It's a question of physics that had to be invented from scratch. Parker is protected by a 4.5-inch carbon foam shield, the width of your hand, that keeps the instruments behind it at a comfortable room temperature, while the front face endures nearly 1,400 degrees Celsius. That's hotter than molten lava, and it does this while traveling at 430,000 miles per hour, fast enough to travel from Los Angeles to New York in about 20 seconds, making it the fastest human-made object ever built. The spacecraft bearing Eugene Parker's name is now flying through the very thing he predicted 67 years ago, and sending back data that's turning solar physics on its head. Here's a mystery that has haunted physicists for over 60 years. The Sun's surface is 5,500 degrees Celsius, but the corona, its outer atmosphere, which extends millions of kilometers into space, is over 1 million degrees. That's like walking away from a campfire and getting hotter the further you go. It defies every law of thermodynamics we know. Heat is supposed to decrease with distance from its source. The corona breaks that rule by a factor of 200. For decades, the leading theory was magnetic switchbacks, abrupt, S-shaped reversals in the Sun's magnetic field that Parker detected in abundance when it first approached the Sun. The idea was that these whiplashing magnetic structures released stored energy into the corona as heat. Beautiful theory. One problem. After analyzing data from Parker's first 14 orbits, scientists made a stunning discovery. Switchbacks are everywhere in the solar wind outside the corona. but they're completely absent inside it. They don't form there. They can't be the heat source. Back to square one. But then, in August 2025, Parker found something that nobody had predicted. A hidden structure inside the solar wind called the helicity barrier. A kind of invisible wall that traps wave energy and redirects it, channeling heat back into the corona in a way nobody had theorized before. In August 2025, Parker did something no spacecraft had ever done before. It flew directly through a solar eruption, a coronal mass ejection, and watched it happen from the inside. Let me explain why this matters. Coronal mass ejections, CMEs, are the most violent weather events in our solar system. Billions of tons of magnetized plasma launched into space at millions of kilometers per hour. When they hit Earth, they can knock out power grids, disable satellites, cripple GPS systems, and put astronauts in serious danger. The 1859 Carrington event, the most powerful solar storm in recorded history. If it happened today, estimates suggest it could cause trillions of dollars in damage and leave parts of the world without electricity for months. We desperately need to understand these things, and we've never been able to study one up close until now. Parker flew through a CME and captured the moment of magnetic reconnection, the explosive snapping of magnetic field lines that triggers the eruption directly in real time. And what it found was disturbing. The protons hurled out by this reconnection event were 1,000 times more energetic than scientists predicted. 1,000 times. That's not a rounding error. That's a fundamental gap in our understanding of how solar explosions actually work. This changes how we model space weather, which changes how we protect our satellites, our power infrastructure, and eventually our astronauts on the way to Mars. For 50 years, we knew the sun produced solar wind. We just had no idea exactly where it came from or how it got accelerated to the speeds it reaches. In 2025, Parker answered both questions. Flying through the corona at record distance, it confirmed that there are actually two distinct types of solar wind, alphatic and non-alphatic, and that they originate from completely different structures on the sun. The slow solar wind, which affects Earth most frequently, appears to pour out of enormous magnetic structures called helmet streamers, vast loops towering above the solar surface. The fast solar wind, the kind that can drive the most intense geomagnetic storms, originates near coronal holes, dark, cooler regions where the sun's magnetic field opens up and lets particles escape. Parker didn't just observe these. It flew through them, tasted them. Its instruments directly measured the density, temperature, and flow of plasma from inside these structures, something that had never been possible before. Parker Solar Probe has made 27 close approaches to the sun. 27 times this car-sized spacecraft has plunged into the atmosphere of a star, surviving temperatures that should vaporize metal and come out the other side with data. Each pass, it breaks its own speed record. Each pass, it tells us something we didn't know before. But here's what strikes me most. Everything Parker is discovering, the corona's hidden heat source, the birth of solar wind, the shocking violence of solar explosions, has direct consequences for life on Earth. We are not passive observers of the sun. We live inside its atmosphere. The solar wind doesn't just exist out there in space. It shapes the magnetic bubble that protects our entire planet. When the sun erupts, we feel it. When it's calm, we depend on it. Parker is teaching us how our star actually works. And that knowledge, ultimately, is the difference between predicting a catastrophic solar storm with hours of warning and predicting it with days. Days could mean the difference between a minor inconvenience and a global civilizational crisis. That's what this mission is really about. We built a spacecraft, sent it to touch the sun, and it survived. And what it's telling us is forcing us to rewrite textbooks that have stood for decades. Parker has at minimum several more years of operation ahead. The sun is currently in the most active phase of its 11-year cycle, which means the next few years of data will be the most dramatic and scientifically valuable of the entire mission. We are living through one of the greatest eras of solar science in human history. And most people don't even know it. If you found this interesting, and I think you did, there's a lot more where this came from. Drop a comment telling me which discovery hit hardest. I read every single one. New video coming soon.